Hello, in this video I'm going to be going over salt hydrolysis. Alright, so first of all, if you have a salt, it is a product of a neutralization reaction. Acid plus base equals salt plus water. However, a salt can be acidic, could be basic, or it could be neutral, meaning if you put that salt back into water, it could dissolve partially into the acid or base, into an equilibrium type problem. And if it's an acidic salt, then it could make your water a little more acidic or a lower pH. So how do we determine whether a salt is acidic, basic, or neutral? First of all, we have to look at the parent acid and parent base. If both are strong acid and strong base, you should have a neutral salt. They'll neutralize each other out. If you have a strong acid with a weak base, you're going to form an acidic salt because it's still a little more acidic. If you have a weak acid with a strong base, then you're going to have a basic salt. However, if you have a weak acid with a weak base, you cannot really determine it because weak is a relative word. One might be a weak acid, whereas the other is a kind of weak base, but not really. Therefore, it's going to be slightly more of a basic salt, but you wouldn't be able to determine that unless you knew the Ka value. So, on this worksheet, if you have weak acid plus weak base, you just say can't determine. On the test, you're going to have something more cut and dry, where you have either a neutral salt, acidic salt, or basic salt. So looking at this first example, we have KCl. So we need to take a step back. Where is this? Get a scratch sheet of paper and write this neutralization reaction out. So KCl is a salt, it's the product. We always have salt plus water on the product side of a neutralization reaction. Then we got to figure out, alright, an acid has an H, a base has an OH. So I have an H plus and an OH minus, and I have to figure out which goes with which ion. This potassium is plus, this chlorine is minus. Plus and plus do not mix, but plus and minus do. So this K and OH are going to come together to form the base, KOH, and this H and Cl are going to form the acid. Alright, now we got to remember whether this is a strong acid or a weak base. How did we do that? So HCl, chlorine, bromine, iodine, remember, are the three halogens that form strong acids, whereas fluorine forms a weak acid. So HCl is definitely a strong acid. I'm going to write SA for strong acid. And KOH, moving this guy just over a little bit. Potassium's right here in the first column. If you're in column 1 or 2, with the exception of magnesium and beryllium, you are a strong base. So KOH is a strong base. Strong base plus strong acid is going to give you a neutral salt. Strong acid, strong base, neutral salt. So this guy is neutral. And we got parent acid, parent base, neutral. Alright, let's do another problem. We've got ammonium nitrate. So that's NH4, NO3 plus H2O are the products of this neutralization reaction. Ammonium's plus, nitrate's minus. So this plus, we got H plus OH minus. This plus is going to go with the OH minus. So it's really NH4OH when you begin. And this nitrate, NO3, will go with this H. To make it an acid, it has to start with an H. So it's HNO3. And I memorized the 6 strong acids, so I write right away, no, HNO3 is strong acid. If I didn't quite memorize it, it has oxygen, I could do that oxygen minus hydrogen rule. 3 minus 1 equals 2. If it's 2 or more, it's strong. So this is a strong acid. Ammonium hydroxide. Looking for ammonium in these first 2 columns, I don't see it. Therefore, it's a weak base. That's the WB. Weak base. So weak base plus strong acid is going to form an acidic salt. Weak base, strong acid, acidic salt. That was pretty fun. Why don't we do one more? Sodium phosphate. Alright, that's our salt, Na3PO4, plus water. And originally, this is plus and this is 3 minus. We've got H plus, OH minus. This sodium plus is going to go with the OH, so that's NaOH. And this phosphate is going to go with hydrogen. Phosphates, oops, that's a phosphide I wrote. 3 minus, 1 plus, you crisscross it, it's H3PO4. And NaOH, is this strong? Yes, Na is in the first column, therefore it's a strong base. This acid, it's not one of the 6 I memorized, so I would go with weak acid. If you forget, you do oxygen minus hydrogen equals 1. If it's less than 2, then it is a weak acid. So we got strong base, weak acid, that's going to give me a basic salt. Weak acid, strong base equals basic salt. And that's the basics of salt hydrolysis.